Fantastic. I hope you've had a good break, a leg stretch. We at that time where I'm personally incredibly nervous and excited for the three companies we're going to be introducing to you in the next few minutes. These are SMMEs who have been focused on using Earth observation technologies in innovative ways. And the first one is an organization called Predict Australia, and we'll be taken through the introduction, the profiling by Jean-Baptiste. Jean, over to you. Enjoy it.
Thanks. Hello, everybody. So I'm JB Leger from Predict Australia. As the name of the company could be very understandable, we are specialized in predictive technologies, and we anticipate dysfunction on different industrial plants in order to save money. The company had a very important industrial footprint in different kind of industry. Of course, space, of course, aeronautics, of course, manufacturing industry, and oil and gas and mining. We are a member of different kind of organization, and specialized. We are a member of the Australian Association for Space and SmartSat CRC. And we develop some project for space in order to predict some dysfunction on different kind of equipment and systems for space industry. We were born in 1999. We have 20 years of experience on different kind of industry, as I said, and we have improved our technologies and our innovation during all along these 20 years. And step by step, we had different kind of functionalities on our technologies in order to cope with the different user needs, and different improvement on the capability to predict and to have early detection of dysfunction. Our solutions is based on three levels. The first one is CASIP. It's a kind of edge computing solution able to treat in real-time data in order to detect as soon as possible some dysfunction and drift of behavior on different kind of systems. When I speak about systems, it's a mechanical system, it's hydraulic systems, it's electronic system, electric system, and different kind of systems. Of course, when we address a system globally, like an airplane, like a rocket, of course, we have to integrate all of this kind of, physics in order to address the global dysfunction of this kind of system. So that's why when I speak about systems and edge computing, we treat also data coming from equipment such as pumps, such as valves, but also some electronic parts such as embedded electronic system, and of course some information coming from computers, such as what we can do for some architecture, IT architecture, to observe Earth, for example. And we have also another second solution. The name is CASM, and this is to manage a workflow after the early detection and warning to the different users. We can address diagnostics, prognostics, proposition of intervention, and different kind of comparison between different use cases in order after that to capitalize on the knowledge-based system. And we have also a capability to provide apps, applications such as CASM apps in order to be on the field with the different information on a mobile or on a smartphone or a tablet. So we work on different kind of industry. You can have a look on these different industrial sectors, and mainly we now present you some use cases related to space. For example, where we work on different purpose for ArianeGroup. We work on the early detection and prediction of the manufacturing system. We work on implementation of massive and real-time data processing technologies for both maintenance and quality in order to predict and to try to anticipate some drift on the quality for the manufacturing of different parts of the rocket, for example, and here on the special machine able to make some friction welding for Ariane 6 tanks. We have also another use case on the implementation of real-time data processing technologies for virtual LED. So it's also for manufacturing process of the different equipment and part of the rocket, and on a virtual LED used in the machining of Ariane 6 nozzles. We have also implemented the technologies, so the same kind of technologies in order to predict. And when I speak about prediction, I mean some weeks and some months before a failure or before a default on the quality of the part of the equipment. And also we work on this prediction on a furnace in order to detect as soon as possible some drift on this furnace. Third use case is on the implementation of complementary instrumentation. So it's not only data processing, but here in this case, it's the implementation of new sensors like IoT in order to have a very good understanding of the health status of some pumps, very important on the production of the propellant process oxidant for the rocket fuel. A fourth use case is related to the implementation of technologies for predictive maintenance on 4-axis horizontal machining center already in the machining of a rocket engine. And the last one, but not the least, is on the implementation of real-time digital data processing for the mill turn using the machining of the combustion chamber. So here is ArianeGroup. We have very important experience on the prediction and predictive technologies used for machining, manufacturing, and the process. The other use cases that we would like to present you is related to Airbus Group, Airbus Defence and Space subsidiary. We have worked here on the application of predictive technologies for Earth observation ground segments. And in this case, this is to increase availability, to improve diagnosticability, and to have a very important reliability of these ground segments. So we have worked, as I said, not only for machine, not only for equipment like pump and valves, but also for IT infrastructure with different servers, different application with different data storage units with different firewall networks devices and so on. So we have worked on that and we have used the same platform able to early detect and warn people as soon as we have this kind of degradation and drift of the performance of this IT architecture. And in order to improve the availability of this architecture and the delivery of the different image for the end user at the end, and to improve the quality of the services for everybody, both for civilian or military purpose. So I would like to thank you very much for your time. I hope that is very interesting for you. I think I have to click now.
Jean-Baptiste, to say that was very interesting would be an absolute understatement. I was riveted. That was fascinating. Thank you very much for sharing that. And I wish you and your team every bit of success going forward. And I certainly hope your telephone rings off the hook after that presentation with many, many people wanting to talk to you. A question though, out of interest,
thank you very much.
It's such a specialized area that you're in. What are the skill sets that you build and employ within your organization? What are the types of people you employ?
Yeah, very good question. Thanks a lot. So we have three kind of people in the company. We have first some engineers able to address mechanical systems, electronical systems, electrical systems, electrotechnical systems, and also kind of systems. So engineers able to understand what the function of the systems. After that, we have some data scientists or other profile of people able to treat data with an in-depth investigation of the data with different kind of artificial intelligence capabilities, with different machine learning technologies and so on. So people able to address the data and not the physics, but the data. And the other profiles on your company is IT and software developer, in order to develop the solution for us and for the client at the end. So we have these three population: engineers for physics in the general way, data scientists, and software developer.
Fantastic. Thank you very much and all the very best. Hope to speak to you soon.
Thank you.
Excellent. Thank you. That was our first SMME for the day. And the second is all the way from South Africa, Swift Geospatial. We're going to be joined by one of the founding directors, Michael Bretzker. Michael, we're ready for you to come on screen. Hi, Michael. Enjoy the next few minutes. I'll speak to you in a bit. All the best.
Thanks, Kamal. All right, great. Kamal, thank you once again for allowing a small company like Swift Geospatial to be represented on such a great platform. Today, I'm just going to be talking about the Swift Geospatial story, how we started and where we are going in the space of just 4 years. So as Kamal quite rightfully mentioned, we are proudly a South African company with a South African team. We started Swift Geospatial in August 2016, so it's been just over 4 years of the company, and we have attracted a very young, talented South African team in-house. We're based in Pretoria with our main focus of transforming geospatial data into knowledge. 4 years ago, we thought that there was quite a big divide between the data and the knowledge. Earth observation data has always been present. It's just a case of how do we transform that data into knowledge for our end clients in order for them to better help them in decision support, and to move people away from being Earth observation experts or GIS or remote sensing experts, but rather move them into a sphere of Earth observation data where everybody can actually use the data. You don't need to be a specialist in that field understand what is happening all around you. And so we formed this team with that goal in mind. The team itself is divided up into various expertise along the lines of IT or development, R&D, Earth observation specialists, remote sensing specialists, GIS specialists. And so this team was formed and put together with that main purpose in mind for decision support and providing knowledge to our clients. Our four main products that we do at Swift Geospatial all revolves around monitoring. We thought that there is this lack of monitoring capabilities when we started Swift Geospatial, and monitoring a point in time is great, but you need to have consistent, repeatable collections and captures of Earth observation data within certain areas in order to promote monitoring, in order to provide, once again, better decision support. The four main targets or industries that we target is agriculture. Agriculture, we see now after this terrible pandemic, particularly in Africa, when we're looking at food security, is a main talking point. And Earth observation data provides us with that tool of telling us what is on the ground and how we can transform that into decision support for governments, for various organizations to use appropriately. So agriculture is one of our main focuses for our monitoring products that we've developed. We also are very heavily entrenched in forestry, both planted and natural. When we're looking now at something like climate change that's happening all around the world, understanding the lungs of the planet is vitally important. So forestry for us was a key element to fight climate change, but also to help those type of organizations understand what's happening on their land. Mining, specifically mine monitoring on a certain frequency to understand things like encroachment, to understand tailings dams, to understand surface, to understand type of artisanal mining that is a massive problem in the African continent, and particularly Northern Africa, to provide that type of insight on the ground. A lot of these areas, when it comes to monitoring, are so large areas that it's very difficult to get human elements to those various areas or to monitor those on a frequency without using satellite information. And then the fourth little one that you see in the bottom is IoT. This is a relatively new section that we're looking at in the company, but looking at it as how to integrate IoT into the various sectors of monitoring. But like I said, this is a story, and this is a story based on Swift. So like any good story, we need a villain, right? And so 4 years ago, when we started Swift, we identified these four pillars as problem areas or the villains in the story. One being big data. It's all very well having big data, but if you don't have the means to process this big data in an efficient manner, then it just remains a problem. You know, you can throw many different types of images at the problem, but if you're not processing it in a logical way with an outcome-based derivative, then it just remains big data. Speed. Speed was always being an issue. You know, if you delivered something within a week, it was considered pretty quick. But once again, if you're looking at a monitoring exercise, if you deliver something in a week or 2 weeks later, what you captured then has changed already. And so the data is out of date and it doesn't make much sense. So how could we address the speed issue? Decision support, once again, is a major driver of Swift. How can we provide decision support to the people that need it, whether it be on the ground or in the boardroom? What we noticed 4 years ago is that people weren't interested in looking at a picture. Whether the picture arrived every day or every week, they were more interested in the outcomes of that picture. So for example, if you're a farmer, if my field is healthy and it's fine, I don't really care. But if there's a developing stress in the field, that's when I need to be alerted and in a timely manner. And then delivering that data. Back then, DVD or external hard drive was seen as the pinnacle, but that is obsolete. And so we needed to address these four problems in an innovative way. And so for Swift, we saw these four problems as a stack, and we decided how can we address this in an innovative way. And so we focused our analytics section of it at Swift to develop this pipeline, this data pipeline of getting the data through to our customers quickly and efficiently. So how did we do that? Point number one, when we're looking at big data, it was very clear and obvious that you can't have rooms of computers and people sitting behind computers clicking away. We needed to move from human at the machine, moving away from models that obviously assisted a lot, but into scripting. And so this was a major driving force for us. We needed to move into full automation. We needed to move into a section where the scripting and the automation could handle this big data arriving at the speed that it does and processing this data in a timely manner. And so for us, the only way to do that was move away from the human element and move into full automation and through into a scripting stack using multiple languages. Speed obviously was one of the main driving forces. So how do we improve speed? Being in South Africa, you know, data connections and internet speed isn't always the best or the most reliable. So we had to move everything into the cloud. And now where we're sitting, we have multiple setups in AWS environments all over the world, which allows us to process on site. So when the Earth observation data comes down, sometimes into your AWS environment, our systems are already set up there. And so we can retrieve that data, process that data in a timely manner and produce results for our clients that are meaningful. And so that took a lot of drive and a lot of effort on our point to push towards this kind of speed automation and be completely cloud-based, where we could provide the speed that our clients require. Decision support. And this is providing that insight that we talk about, providing knowledge. And I keep on drumming this to everyone out there. Data is one thing, but if you don't provide the knowledge of the insight of that data and helping an organization or a government entity to use that insight to assist its people or to understand how much crops, to understand the yields, to understand if there's artisanal mining or encroachment or the need of development within a certain municipality. It's about providing that decision support. It's about providing that information, that data into information for our clients. And once again, it's not about providing that to just your GIS experts or your remote sensing experts or your engineers who understand the back end. It's more providing that information to everybody and putting it into a simple to use environment that everybody can use the data on a daily basis. And so that was a major driving force. As much as our innovation came on the back end, it was also on the front end of understanding our clients' needs and what they want in order to help them do their jobs better. And how that was achieved is by putting everything online. We had to move online. We had to create dashboard environments, mobile applications that anybody can use the data anywhere. Whether you are the big CEO of the company sitting in your weekly meeting to understand what is happening in your forest, or you are out in the field on a tablet in real time, understanding as the data comes in and processing it, what is happening. I'm standing in the problem area. So we had to answer both factors. And so for us to innovate and move to an online system, providing this type of platform where everybody can consume the data was a major driving force for Swift Geospatial to ingest the Earth observation data and provide the answers to our clients. And at Swift, we encourage failure. It's one of those driving forces. We encourage everybody to go out and if you've got an idea, motivate for it and go for it. Because if you're not failing, you are not innovating. And so for Swift, over the past 4 years, this is just the start. I guess sky's the limit. So thank you very much for listening.
Fantastic, Michael. I love that. Fail fast and encourage failure, or else you're not innovating. That's very, very, very positive. And congratulations for surviving the first few years. I think that's the most trying. Tell us a little about your dreams for Swift going forward. Where are you seeing it? I know you've done really well in forestry thus far. What are the dreams for Swift going forward?
Yeah, thanks, Kamal. Dreams have changed as it's gone along. Initially, it was just to put bread on the table, to do something that we love, And now after 4 years, I get flooded with CV requests, internship position requests. And for us now, the drive is now moving towards, hang on, we can do this. We've got the data, we've got the resources. And in South Africa, we've got probably some of the most intelligent minds. It's now about trying to grow the company in that facet, and bring people into an environment where they can experiment and they can fail. So for us, it's just about growth at the moment, and still keeping a firm focus on what's made us to get to where we are thus far.
Fantastic. And I hope we've managed to help you in some little way after today. So Michael, all the very best to you and your colleagues at Swift. Hopefully we'll see you in the future as one of the large Earth observation businesses that's going to be talking to us. Very good. Thank you, Michael. To round us off on the company profiling, we have Piset all the way from China. I'd like to welcome Dr. Tao. Dr. Tao, thank you for joining us. And we're looking forward to your introductory comments on Piset. Welcome, Dr. Tao. I'll leave you to it.
Okay, thank you very much, Chairman. Hello world, greetings from Piset, Beijing. We are a company based in China. Piset is an IT company, so we are very much focused on the satellite application technologies, which including the remote sensing and also navigation. Innovation actually is always one of our objectives. We did from the scratch develop our own system. We call it PIE, Peaks Information Expert. This is a comprehensive software system for handling the remote sensing data. Based on this platform, we developed many solutions which has been successfully applied in the China nationwide. And actually, Piset is also one of the first GEO associates member from last year. In this talk, I give very brief introduction about our company, our solution technologies, and as well as I will talk a little bit about our engagement with the GEO activities. So we are not a we are also very young company, funded in 2008. At the beginning, we only have like 15 funding members. So far, we have 1,300 employees. Even we built our own research institute. We have like the 80% staff, they are professionals. Right now we have almost 100 PhD researchers. So they are doing the very excellent R&D jobs here. So not only in China, actually we are also expanding our business globally. We have our international headquarters in Hong Kong and also set branch companies in Australia and the UK, London, Geneva, Switzerland. Right now we are setting the branch office in India and also Thailand. So we are expanding our business. So just like I mentioned the PIE, which is one of our flagship product. This is conventional, I mean the equivalent to other famous software, conventional software. We can handle all remote sensing data from the optical, from the microwave, even the drone, the hyperspectra, all data we can handle, even the GIS map. So all these things, based on this platform, we create a lot of solutions has been applied in the many fields, like the disaster reduction, land resource mapping, environment protection architecture, meteorological, many application sites. So I'm not going to list all, but a lot of applications has been done. So the basic modules, we call PIE basic. You can see it's very friendly interface. Users can very easily to handle the data informations. And some modules like the PIE author, which able to generate the author image and also can mosaic the Soren's pictures together to generate author maps. It's very good for the PI for drone applications, because PIE SAR it's very good tools for handling the SAR data. Hyperspectra is handling hyperspectral data either from the aircraft or the satellite. The PIS IAS, this is new module developed ourselves. We use a very new algorithm to very precise to segment the features, map, and handling GIS information. But different things because we handle with a lot of meteorological ocean applications. So this map function is really good for like the fluent data, like the ocean wave and also the air flow, this kind of things. Visualization also included. So PIE UAV is for the drone applications. We can create the author map and also can generate the 3D cloud points, make a 3D models. I do agree with the previous speakers. Actually, conventional software platform is really powerful, but we need to provide more what I call accessible tools for the users. That's why we also shifting to the cloud service. Recently, we released we call PiEngine. It's completely a cloud service. We provided the functionalities to handling all data. So, and also we store the data sets there. Users can find the data and also tools is there. They can immediately work, get their job done, and publish the results, put to the applications, all things on the cloud. So we are working on this one. This is already released. Cooperating with cloud providers like Amazon and also Alibaba, this kind of cloud providers. So this service right now is working in China. We hope soon we also can take to the outside of China. Here are some features. Like just I mentioned, we also host the data sets and also provide the data links. So user does not need to look for the data. They have rich clues from our platform, and the computing power capacity is also ready, and intuitive of the calculation results. User interface is a completely cloud service, ready for the use. And here are some modules are just very brief to introduce here. The data processing we call the PiEngine Factory, which cooperate with algorithms either developed by ourselves. Actually, the good things we also can take. We also encourage the user to contribute your algorithms, and you can generate communities, and you organize some groups and maintain or develop some algorithms in your own way. We just provide the platform service. And here shows some examples AI function. Actually, this platform also combined a lot of the cutting edge technologies. Here is the AI. Users can upload their training samples, and then they select the data sets and define the task. Then let the cloud to do the jobs. And here show some examples. Automatically extract the road networks and also small features like vehicles, ship boats, and a lot of things you can done with very high accuracy. Here is a movie. I show you the, okay. I don't know if it's work or not. Okay. Okay, that's fine. Here is the engine server. So it only, okay, the video come back. So it's showing how to extract the aircraft from the image. All this one is done on the clouds. You don't need to care about data sets, just what to mark some samples. Yes, okay, next. So because the remote sensing works normally involves a lot of data sets, a lot of informations. It's not easy to handle management this kind of data. So we also provide facilities to manage all data sets on the cloud. So also including data publishing. For the skilled users, even they can use Engine Studio to do the programming, to customize, to do a lot of high advantage works. Okay, so last I will introduce some engagement, Piset, work with GEO. So we participate GEO week from the 2018 in Kyoto, also later in the Kampala last year, and this time virtually. And we not only participate in the conference, we also propose our what they call work program to the GEO work program. So one of our proposals has been accepting the GEO community activities. That is what they call set up, build up industrial platform for the innovation. And we do believe if we have a big vision, we can see the space technology, this market need to carefully cultivate. So that's why the capacity building training is one of the key for this market. We very actively engaged in this activity. Cooperate with AOGO, we conducted a lot of training, capacity building training in the developing countries, like Sri Lanka, and also now Nepal. And last week, we also conducted training in our company on site. A lot of trainees from the developing countries attended our training sessions. So last but not least, this is slogan our company serves the Earth space community. So our philosophy actually is quite similar with the previous speakers. We dig the value from the data, generate information and knowledge, but not end this part. We go further, using the knowledge and information to serve the user, provide a service, trying to get the remote sensing technology directly served to the end user. This is our philosophy. Thank you very much.
Dr. Tao, thank you so much for that, and congratulations. You've been around for more than 10 years. You've done some incredible work with GEO already, particularly the GEO work program. So I think a lot of SMMEs around the world are looking at you with huge admiration right now. If you were to give the other SMMEs a word of advice on how you've managed to scale your business around the world, build such beautiful skills and solutions, what would that be? What word of wisdom could you share with us?
Oh, actually, because what we think is like the remote sensing is kind of high technology, is quite useful, but we need to generate their values and implement these values to the end users. Because for the end users, normally they don't care about the data, they don't care about knowledge, they care about the what results. So that's why we paid our efforts to do the data processing, to do the software development, But finally, there is gap. How can we fill the gap? Implement these values, give these values to the end users. That is what we are doing. So that's why we are building up the cloud service or generate solutions. We're trying to shift this value to the end users. If end users have value, then we have a business.
Fantastic. I think that's really focus on creating value at your end user. It's brilliant. Thank you very much. So Dr. Tao and all of the SMMEs, thank you all for your participation. All the very best with growing your companies into the future. That brings us to the end of the first session. We're going to take a short break. We'll return at 10:50 South African time, which is GMT +2, and we'll go straight into 3 separate streams, one being the expert talk, where we'll look at promoting skills and capabilities, and of course, a very exciting panel discussion, a topic that we've been covering already, public-private partnerships, and how can we improve that collaboration, and then the first ideation workshop on facilitating all of you into coming up with some brilliant ideas on how to leverage EO better. Thank you all very much. Enjoy the short break. We'll see you in a few minutes.